maupun downstream, itu supply gas kita itu yang garis hitam itu. Jadi kalau kita do nothing ya. Sementara demand-nya dari tahun ke tahun makin meningkat, stabil kalau kita lihat. Nah, untuk itu kita masih punya beberapa project di upstream untuk produksi gas strukturnya, yaitu diantaranya adalah di Blok A Aceh itu oleh Medco, itu nanti untuk pupuk maupun PLN dan industri setempat. Kemudian juga kita punya proyek rencana IDD, sebagian sudah produksi, sebagian besar belum. Dalam progres juga Jambaran Tiung Biru, mudah-mudahan tahun depan sudah bisa on stream. Kita juga punya Eni Marrakesh yang segera berproduksi juga, dan juga Tangguh Tren 3, kita juga punya produksi gas yang banyak nantinya, ada proyek sana juga. Dalam rencana adalah di Genting Oil, di Papua, dan Masela Abadi. Nah, itu yang garis biru maupun garis merah, itu adalah rencana supply gas apabila nanti itu kita on stream, proyek-proyek yang sedang berjalan, maupun nanti misalnya ada di kemarin ditemukan gas oleh Repsol ya, di mana itu? Aduh, saya lupa namanya, jadi di Sumatera gitu ya, ada 1, kira-kira 5 TCF itu. Itu ya adalah potensial gas itu yang nanti warna biru itu. Nah, sehingga kalau kita lihat grafik ini, kita akan kelebihan gas. Kita akan mengurangi ekspor. Untuk itu jalan satu-satunya adalah bagaimana kita membangun infrastruktur gas bumi ini. Upstream-nya sudah direncanakan, downstream-nya juga mestinya harus seperti LNG terminal misalnya, kemudian juga pipa transmisi, distribusi, SPBG dan sebagainya, mini LNG dan sebagainya. Next slide. Nah, ini kalau kita lihat demand atau pemanfaatan gas bumi dari beberapa sektor, itu yang ekspor kalau kita lihat yang paling atas, makin tahun makin lama kita akan mengurangi, dan di dalam RUN adalah 2035 kita akan nol itu ekspornya. Kemudian warna biru adalah pemanfaatan gas untuk industri, kalau kita lihat dari tahun ke tahun juga makin meningkat. Kemudian untuk listrik juga kalau kita lihat cukup stabil pemanfaatan gas bumi. Kemudian untuk rumah tangga itu untuk jar gas itu masih sedikit, memang perlu kita membangun secara masif pembangunan jar gas ini untuk mengurangi juga impor LPG kita karena gas ini untuk memasak. Untuk transportasi juga masih kecil, sehingga kita perlu juga membangun infrastruktur SPBG yang cukup masif, baik itu nanti berupa CNG maupun LNG untuk kapal, untuk kereta api, untuk truk besar begitu ya. Nah, kemudian juga dari tahun ke tahun yang cukup meningkat adalah untuk pupuk dan petrokimia. Kita rencana membangun pabrik pupuk, pabrik petrokimia, metanol, dan turunannya. Untuk lifting ini cukup stabil pemanfaatannya, jadi untuk memproduksi minyak menggunakan gas lift. Itu kalau kita lihat antara demand dan pemanfaatan gas di dalam negeri dari berbagai sektor. Slide berikutnya. Nah, ini kalau kita lihat ya, tadi sedikit menyinggung kita masih impor LPG cukup banyak begitu, 77% kita masih impor, subsidinya juga masih 70-an triliun. Nah, salah satu cara untuk mengurangi impor LPG ini adalah memproduksi LPG dari dalam negeri, dari lapangan yang mempunyai kandungan C3C4, propan dan butan. Nah, itu kita sudah mengidentifikasi ada di lapangan gas, ada 6 lapangan gas yang bisa memproduksi tambahan LPG hingga mencapai 500.000 ton per tahun gitu. Nah, ini perlu pembangunan infrastruktur mini LPG di dalam negeri, ya. Satu. Nah, kemudian jaringan gas kota. Jadi itu yang warna hitam itu adalah penambahan gas LPG dari lapangan gas yang existing. Itu perlu kita membangun mini LPG di dekat-dekat lapangan gas. Kemudian yang warna merah adalah jargon minimum paling nggak 500.000 sambungan rumah tangga, kemudian sampai dengan 1 juta rumah tangga per tahun. Pikiran kita, katakan kita mencapai separuhnya gitu, di tengah-tengah 500.000 sampai 1 juta, ada 750.000 per tahun. Nah, itu kita berharap dapat memanfaatkan gas bumi dalam negeri hampir mencapai 292 mmscfd. Kita perlu membangun jar gas baik dari APBN, dari Pertamina, dari PGN, maupun investasi dari swasta. Tadi Pak Agus sudah menyampaikan mengenai kebijakan harga gas ini, apakah disubsidi infrastrukturnya, atau harganya, dan seterusnya. Slide berikutnya. Nah, ini kalau kita lihat juga kita masih impor bensin banyak begitu. Nah, salah satu upaya untuk mengurangi impor bensin adalah kita membangun infrastruktur bahan bakar gas (SPBG). Itu rencananya PGN itu akan membangun banyak infrastruktur gas untuk kendaraan, baik itu SPBG berupa CNG maupun mini LNG untuk kapal, kereta maupun kendaraan-kendaraan besar seperti truk-truk dan bus-bus. Itu kalau kita lihat di warna merah itu rencana pembangunan BBG yang akan menggantikan bensin dari rencana PGN, karena sekarang Pertamina sudah bergabung dengan PGN, maka di bawah koordinasi PGN. Slide berikutnya. Nah, ini 88 gas yang mengandung C3C4 untuk kita dapat memproduksi tambahan LPG sehingga mengurangi import LPG, yaitu di PHI Jambi Merang, kemudian di wilayah kerja SOT Jambi B, kemudian di Energi Mega Persada Gebang, di Mandala Energi, ini masih project supply, kemudian Topik Energi Pandan, ini existing supply, tinggal ditambah kapasitasnya, kemudian di Southwest Bukit Barisan, ini project supply. Kemudian totalnya itu hampir mencapai 535.000 ton per tahun. Ini perlu dibangun infrastruktur, silakan swasta, siapapun yang berminat untuk mengikuti proses daripada pembangunan infrastruktur ini melalui tender ataupun melalui bid contest dan sebagainya. Next slide. Nah, ini rencana PGN, kalau kita lihat memanfaatkan gas, begitu ya, untuk transportasi baik darat maupun laut, itu di tahun 2025 ditargetkan akan memanfaatkan gas bumi hampir mencapai 400 mmscfd. Itu dengan membangun SPBG yang tadi saya bilang CNG maupun pakai LNG itu untuk 11,3 juta bus dan truk, kemudian 17,2 juta mobil penumpang, dan 32.000 kapal laut. Nah, ini juga nanti termasuk di dalamnya adalah transportasi darat kereta api. Nah, ini perlu dibangun infrastruktur pipa maupun mini LNG untuk dimanfaatkan sebagai transportasi maupun di darat maupun di laut. Slide berikutnya. Nah, ini Indonesia Natural Gas Infrastruktur yang existing saat ini ada, itu di 2019 itu untuk transmisi pipa itu panjangnya 4.900 km, untuk pipa distribusi 6.000 lebih kilometer, untuk pipa yang dibangun sendiri, kebutuhan sendiri oleh industri itu ada 75 km, 3 unit LNG kita punya di Bontang, di Tangguh, dan di Donggi Senoro. Regas kita punya NR di Laut Jawa, kita punya FSRU di Arun gitu. Nah ini ke depan kita akan membangun juga beberapa receiving energy terminal ya, baik skala besar, sedang maupun kecil. Slide selanjutnya. Nah ini rencana maupun existing, kita akan membangun infrastruktur gas bumi, baik itu pipa transmisi maupun FSRU maupun mini LNG. Itu yang pipa itu misalnya ya, itu yang akan kita bangun di untuk menyambung pipa dari Sumatera sampai Jawa, itu pipa dari Dumai ke kawasan industri Semangke. Itu lebih kurang sekitar 400 km. Itu biayanya kira-kira 350 juta US dollar. Itu rencananya kita mengajukan dengan dana APBN. Kemudian yang di Jawa itu yang belum nyambung itu dari Cirebon Semarang. Nah itu panjangnya kira-kira 250 km. Nah berdasarkan kajian itu membutuhkan biaya 250 juta US dollar. Itu nanti nyambung sampai ke Jawa Timur. Nah Gresik Semarang sudah hampir selesai. Nah, itu kalau nanti 2 pipa ini nyambung, maka nanti dari Arun sampai Jawa Timur tuh pipanya sudah nyambung. Rencana juga ini pakai dana APBN. Kemudian kita juga masih ekspor gas kan ke Singapura dari Natuna. Itu nanti kalau sudah ekspor Singapurnya berhenti, maka kita akan membawa gas itu ke dalam negeri lewat Batam. Itu pipa West Natuna WNTS itu akan disambung ke Pulau Pemping sepanjang 4,2 km oleh PGN. Kira-kira biayanya ini karena offshore cukup besar, 70 juta US dollar. Itu untuk pipa transmisi nanti juga akan dibangun oleh PGN, dan pipa jaringan rumah tangga oleh Migas, PGN, Pertagas maupun BUMD dan swasta. Kemudian kita ada rencana juga membangun terminal LNG di Cilacap, kemudian di Jawa Tengah maupun Jawa Timur, itu ada FSRU PLTU Jawa 1, kemudian juga mini-mini LNG untuk listrik di beberapa daerah di Indonesia sampai dengan tahun 2021 ada sekitar 6. Gitu. Satu sudah ada di Sambera, di Kalimantan, kemudian di beberapa tempat. Slide berikutnya. Nah ini tadi sudah disampaikan oleh Pak Agus ya, slide ini mungkin lanjut saja. Itu ada yang hitam adalah pipa hulu, yang warna hijau tebal adalah existing pipa, yang warna bintik-bintik biru adalah sedang dibangun pipanya, itu dari Gresik ke Semarang hampir selesai. Kemudian yang merah adalah rencana tadi yang saya sampaikan di kawasan ekonomi khusus Semangke ke Dumai, kemudian Cirebon Semarang, itu yang warna titik-titik merah. Lainnya adalah FSRU yang existing maupun yang rencana dibangun untuk keperluan listrik maupun industri. Kemudian juga ada mini regasifikasi LNG, itu yang gambarnya ada di peta-peta itu. Slide berikutnya. Nah ini gas juga menjadi salah satu faktor di mana Bapak Presiden tahun 2016 itu telah menandatangani perjanjian Paris untuk mengurangi gas rumah kaca. Nah salah satunya ya adalah kita harus menggunakan energi bersih. Yang fosil yang paling bersih adalah gas bumi, juga EBT lainnya. Ini akan mengurangi juga emisi rumah kaca kita. IDD di Isnatuna ini yang banyak banyak CO2-nya ini udah lama sekali, udah 30 tahun tidak terbangun fase produksi yang mudah-mudahan ke depan bisa terbangun. Jambaran Tiung Baru mudah-mudahan tahun depan on stream. Masela Abadi ini juga perlu mencari pembeli gas bumi yang pasti gitu, menandatangani sehingga ini cepat dibangun. Kemudian di Genting juga rencana akan dibangun petrokimia. Kemudian Tren Tangguh
on the left side, you can see the city gas and the BBG fuel, which is a transportation fuel, comprise a very small amount of the entire natural gas consumption. The government has made several progress, particularly on the city gas, to minimize the LPG import to support the domestic consumption. It is a commendable action. Nevertheless, it is not suitable to absorb the large-scale gas that is Indonesia producing right now. So we will touch on the power generation, and we will later discuss briefly on what the industrial sector would look like. So let's first understand what is the role of gas in the global power sector. In short summary, it is a competition with coal. Different countries have different reasons for adopting gas. You can see gas as a proportion of the power sector for different countries, in here represented in green. We can see that in North America, they have a cheap and abundance of gas, with a shale gas boom happening in the US. In China and India, we have seen earlier that there is an increased pollution driving the government to also decrease the gas consumption over time. In Europe, the increasing pressure on the climate concern has also shifted the region away from coal. While in other Southeast Asian regions, there is a stronger gas incumbencies. You can see the comparison between India, Malaysia, Thailand, and Vietnam. We can see that there is a stronger footprint of gas within the power system. And secondly, however, we need to note that these countries are not major coal producers. So the story for Indonesia as the world's second largest coal exporter would likely play out quite differently compared to these countries. The lessons that we can take in planning for the baseline, we can look at the power sector. The power sector has been overly aggressive, assuming for the demand growth. Between 2015 and 2019, the government has repeatedly downplayed the projection from initial number of The outcome of this is the growth of installed power capacity has been happening at different paces. You can see that the total capacity has been growing, while the gas capacity has largely been stagnant. And the end result is that Indonesia today has a substantial overbuild of coal-fired power plants. Undoubtedly, there are several projects using gas that will be coming online in the coming years, namely the PLTGU Jawa 1, which will be coming online from LNG to power project. But the big picture that I'd like to bring here is that today, with the aggressive assumptions made by the government, we have had a very rapid expansion of the coal-fired power plants. And the next slide will explain to you why is this important in understanding the gas role in the power sector. In here, you can see the PLN coal demand. We can see that the cost of locking in the power capacity has been the accelerated decline of PLN coal power generation. Post-2020, we will likely see that the PLN will reduce their coal-fired power plants operations, while the new independent power producer will continue to increase. Post-COVID-19, PLN will be forced to shut down a lot of their coal-fired power plants to accommodate the decrease in demand. So in summary, today we have an overbuild of coal-fired power capacity. And the big question remains whether gas would be able to dislodge coal in the entire power sector. The potential lifetime mismatch between gas supply and power plants has been discussed earlier. And we also need to remember that gas is a long-term commitment, and therefore any planning implementing it need to be very sound. There has been plan about the utilization of gas in a small-scale LNG across different parts of Indonesia, and such a decision could be good depending on the basis of economics. But in summary, gas could be a good opportunity, but it should not be a locked-in liability like we encounter with the coal power. If gas cannot dislodge coal, its existence in already overbuilt regions such as Java and Sumatra will remain an open question. And this also highlights to us the importance of setting a realistic baseline and projection of forecasting the future gas demand. On the screen, we can see the industrial gas use comparison across different countries, and we can see represented in the green color here that industrial use in Indonesia, which includes the fertilizer industry, is quite substantial compared to other countries. So recently, the government implemented the new regulation of the gas price, particularly for the 7 industries with a $6 per MMBTU pricing. Now, we should see this as an effort, and a commendable effort, to increase industry competitiveness. We can see on the left side of the chart that different industries has a different components of gas price as part of their production costs. We can also see in the global landscape of Indonesia to see how PGN is currently retailing their industrial gas, with the chemical sector accounting to much of the consumption. The big question that remains to be answered is whether the model that was based upon when we decided that $6 per MMBTU was to be implemented to the 7 industries requires an update with the current demand level. We need to reconsider whether the best value for the loss in state revenue has been acquired, that the gas will need to become a tool as a runway for industry to take off. On the third part, I would like to briefly touch on the upstream sectors, which is a story of continued volatility. It is not a surprise that since 2014, the upstream sector, which is namely the exploration and production of gas, has been undergoing quite a substantial decline in investment. It is possible that within the coming years, gas price will increase again. But the big question is whether an increase in gas price would be sufficient to increase the investment of gas in countries such as Indonesia. I would argue that smaller producers would likely be trapped within the continued volatility and the movement of giants in absence of a real and a radical change in policies. Suppose today that several years from today, gas price will increase. With an increase in gas price, the quickest responder to this price would likely be those countries which already have potential gas resources ready for FIDs, that is the construction of LNG plants. Although it'll take several years for it to be completed, these countries would likely have an edge with the lower cost of gas and the not necessary of doing an exploration campaign. Secondly, the US shale is very likely to increase their production capacity as well. With the shale expanding ability of production very quickly, it is very possible that US shale could rise back up again. And thirdly, I'd like to introduce you to the renewable energy and storage, which is rarely being discussed in countries such as Indonesia. But in other countries which are very liberalized power market, gas is starting to compete very strongly with renewable energy and storage. The use of the gas power in many countries is primarily used as the peaker plant, that is to support the power providing capacity when the demand is high. Now, as renewable energy and storage of batteries are becoming more cheaper, batteries will likely eventually replace the role of gas peaker plants in the future. So what will happen when all these three kicks in? And the likely result would be a decrease in gas price. So this big question leaves us with an open question of how should Indonesia proceed? I will not have an answer to give to you today, and perhaps it is something that we could discuss at length in other occasions, but I'd like to re-emphasize the need of a change in reflecting on the gas market globally. Looking at resources alone is insufficient because the demand and the movements of these giants will likely trap countries such as Indonesia within a continued volatile cycle. Another challenge which we also need to consider is that the IOCs, the international oil companies, are under continued pressure in the past decade. Continuous asset write-downs, cash flow challenges, and shareholder return challenges is a prominent issue in the sector within the past decade. In the past 6 months alone, $18 billion of gas assets has been written down in Australia. A similar trend is happening in the United States in recent time. The big message here is that indeed, the times are changing. There's been more competition for capital in the E&P sector, and the companies that Indonesia has been relying upon to develop and invest in exploring its gas resources 2 or 3 decades ago are not the same company anymore in terms of how they spend money and how they prioritize their assets. If I could summarize the pressures that is being faced by the gas sector, the number one is the financial returns. With a growingly competitive market, only the cheapest gas will survive and come on stream into the market. We have earlier examined how the continued volatility of the market will affect the development of the upstream sector. Secondly, we have also briefly touched that the technology landscape is changing. The least cost technology remains a developing question. The developing of the storage and renewable energy may provide answer for some market to replace the gas and the pickup plants. This has been happening in recent years and likely will continue to do so. While it may not touch Indonesia directly, as we are lying in a single buyer market in present time, when it happens in other countries, the wave and repercussions toward the capital market will undoubtedly come. And lastly is the environmental pressure. At the end of the day, the aggressive target of having a net zero emission by 2050 will slowly creep into the capital market. With the public, the politicians and investors paying attention to the subject, this will likely remain a big question mark that will pressurize the gas market in the future. I'd like you to leave with the following takeaways. Is that the first one, that any decisions that Indonesia made should be based upon sound and up-to-date plans. Where regulation has been issued, it's worthwhile to consider and reconsider whether the value that it has been expended upon is worthwhile. Secondly, Indonesia needs to be careful on locked-in liabilities. We have earlier examined the effect of locked-in liabilities toward PLN and the coal-fired power plants. Secondly, we need to understand that there's been a changing IOCs and a tightening of competition. Volatility will remain the key word for putting a 30-year investment in the gas sector. And lastly, we should always see gas as a window for increasing industry competitiveness and not solely as a tool for consumption. Keep watch on the shifting energy landscape, as there's a lot of new technologies coming on the market, which brings additional layer of uncertainty into the gas sector. In a sense, Indonesia needs to be ready to recalibrate the baselines. It needs to be ready to look at the historical record and look at the present and the future challenges and acknowledge those challenges in making a plan ahead. Creating an aggressive forecast does not translate to results. We have seen it happening in other sectors, whether in Indonesia and overseas. So the country needs to be careful in making the steps moving forward. It needs to be careful to make sure that the pathways ahead of us remain to be a reasoned approach. In closing, I'd like to re-emphasize the point that if and when gas is utilized in Indonesia, it needs to be considered as a runway. It needs to be considered as a runway for industrial takeoff to increase the competitiveness of certain industries. It should not be treated as a railway for consumption, as consumption does not increase the economic benefit of the long term in the country. And we need to remember, as a runway, the runway does not last forever. There will come a day that having a natural gas resource will not bring additional value, especially when the scarcity of capital does not allow it to develop. So again, if and when Indonesia choose to develop its gas, it is best to be used as a runway to take off the industrial competitiveness. And with that, I'd like to close the presentation today and open for question. Thank you and good evening.
Thank you to Mr. Putra Adiguna, such a tremendous presentation. I hope this presentation will give us about global and Indonesian gas business landscape. To shorten our time, shall we begin to the Q&A session to keep this on schedule? Okay, for the first Q&A session, the first question is, how Indonesia sees about upcoming increasing global gas production and global demand regarding these pandemics? What the key actions to do? Maybe I will repeat it once more. How Indonesia sees about upcoming increasing global gas production and global demand regarding this pandemic? What the key actions to do? Please, to Mr. Putra Adiguna.
Thank you for the question. So when we look at the global pandemic that right now is happening globally, there's a drop in gas demand, anything between 3 to 4%. I think the point right now is really for the industry to survive, because everybody is really struggling to keep up with the demand. Like, for example, recently, just picking an example of one of the industries that Indonesia has picked to have a lower gas price. The ceramic industries has received a lower gas price partially, but at the same time, the export coming from countries like India and Vietnam is still increasing. So I think if we're looking at it from the pandemic perspective, right now, everybody is on survival mode. But it's also an important time to actually look at our strengths and weaknesses. And this comes back to my earlier point that the government regulation to lower the gas price for industry is a commendable move. But we need to remember nations. It was based upon a long regulation which was modified in 2020. I'm certain that our colleagues and the ESDM ministry has done a lot of research on it, but it would also be nice that if we can have a more transparent understanding on what is the basis on the selection of the industries and what is the multiplier effect that can be achieved by selecting a certain industry. Because Indonesia do need to take side, right? I mean, we need to take, for example, if we want to pick fertilizer as the winner on this battle, or the methanol industry, we do need to look at the map and we do need to prioritize certain industries, looking at the regional export and import market. Because we also need to remember that right now the tendency to avoid importing gas, right? We're still basically a net producer. But what we also need to remember is that when countries such as India can obtain their gas at a much lower price from Qatar, eventually their fertilizer will end up on Indonesian shore. So it's going to be a combination of balance between Indonesian trade protection as well. So it's not a simple question. I think everybody is on a survival mode right now, but it is a good time for us to revisit on our assumptions and look which industries would present the best opportunity to increase the way forward. Like, for example, like today, Indonesia has the plan to increase the biodiesel consumption. Is that a big option? I don't have an answer today. Like the colleagues from the University of Indonesia must certainly knows that it will take a lot of methanol and probably in other sectors as well. So again, this is a good time for us to revisit our assumption and revisit the markets. But we also need to consider not just on the gas side, but the end product competitiveness on various kind of industries. I think that would be my answer. Thank you, Mas.
Okay. Thank you to Mr. Putra. Now, shall we continue to the second question? This is from Mr. Kes Omen. This is actually a long question. Okay, I will repeat you 2 times. As it looks increasingly likely that gas resources in Indonesia may become trapped, would it not be wiser to skip this stage altogether and instead focus all effort on the next stage? Example, renewables. It is important to consider that renewable energy could also be used to produce hydrogen and in turn produce fertilizer. Australia is increasingly looking at this. how about do you get it, Mr. Putra?
Yes, thank you, Mas. I'll try to answer the question,
Okay.
Mas Randy. So thank you for the question, Kees. If you ask me, my personal opinion, whether Indonesia should skip and move to renewable entirely, I guess at the bottom line, it'll comes down to the question of economics, right? I mean, of course, there is the consideration that Indonesia is an archipelago, and there's a consideration that there's a lot of assets that's already been installed. But at the end of the day, it'll comes down to the question of economics. Like you said, that Australia right now is competing between the renewable energy of solar panel and perhaps the future hydrogen as well as gas. I think the context for Indonesia is we need to look a bit closer, that there are several key fields of gas that are just about ready to be exploited, so to say, like the Masela field. So those gas may still need to go online, perhaps. That's not an answer that I could give. But I guess the point is we need to compare what are the options when we compare between the renewables also with the gas industry. As for hydrogen, as I understand that it's still being evolved, right? We're looking at least 2 or 3 decades before hydrogen could eventually become more economic. But then we also need to consider, what does economics mean? Is it an economic at a European level, American level, or at Indonesian level? But this is an interesting question indeed. And this actually comes back to our earlier point, is that when we want to construct a heavy infrastructure, what do I mean by that is that when we want to construct, like for example, like a dozen of LNG regasification plants, all of this will need to be considered. But of course, domestically, the government would want to consider to produce the gas because it's still considered an asset. So in summarize, I think the big question mark of the entire Indonesian gas industry lies in the Masela project. Everybody would be looking at that project. If Indonesia can take it off the ground, I would hope that it would be directed toward the industries and not the power sector. But then it's an open question, right? I mean, if Masela cannot become on stream, then of course, within the next 10 or 20 years, or even 30, the landscape of energy may start to shift very slowly. But it's a very good question. Thank you.
Thank you to Mr. Putra. And we still have 10 minutes. Maybe we want to add one final last question. That is from Mr. Shaif Usman. Why the gas price in Indonesia always increase, never decrease, like the international gas price? Quite simple.
I think if I could answer, thank you, Mas Said Usman. I think earlier presenter, but of course Iswanto and Pak Agus would be in a much better place to answer that than me. But in short, is that what you're looking at, the international gas price, is basically a free market price. While in Indonesia, we basically already have what is called the plan of developments, right? As we develop a certain gas field, for example, the Masela, the first stage POD was developed at $7 per MMBTU, for example. So that is basically the baseline commitment of the price, right? What you're looking at when I earlier presented about the gas price is actually the free market price. What do I mean by that is that everybody is basically selling at whatever price the market is offering. There is no locked-in baseline. Even if a project, for example, even if a project is developed in the US with $5 per MMBTU, when the market price in the US drops to 3 or drops to 2, they would need to decide whether they're going to sell it or not. And then that's what is called the short-run marginal cost of gas, whether they will be able to break even the cost of gas or not. So in summary, there is a different, Indonesia's gas market and gas price is fairly regulated to compare to the global market price. So if you ask why is the global price could be decreasing today, it is because it's a very free and globalized market. 10 or 20 years ago, people are still protected from the gas from Qatar or from the United States. I'm sure people in Japan would not imagine of having a gas coming from the Gulf of Mexico at their doorstep. But such globalized market that we're seeing today means that the gas market in Asia, for example, which Indonesia previously used to supply a lot to Japan, a regional market has been broken. It has been broken by the competition from Qatar and the United States. So in summary, with a global and a free market, gas commodity market, everybody's basically selling at their rock bottom price, sorry. And if we want to compare it to Indonesia, unfortunately, some of our gas are still quite expensive to develop. And then it's, of course, the question for the government, whether it's worthwhile to increase the gas, decreasing the government revenue or not. And that's all a big question that will need to be answered both by the technical people, the economists, the trade experts, and all that to be involved. So that's, I guess, the long and short summary of my question, that Indonesia's gas price is not as liberalized as we're seeing in other places. Thank you.
Thank you to Mr. Putra. Actually, more question comes to our webinar. Maybe the fourth question is maybe to how the prediction or forecast about upstream, especially for gas production after the US elected the new president that will stop gas fracturing in US.
Okay, thank you, Mas Randy. Thank you for an interesting question here. Yeah, I mean, nobody knows what's going to happen, right, with the market. But basically, in summary, with the new administration in the US, there is a possibility of gas will be reduced. Now, one thing we need to understand is that, just to give a broader understanding, is that some of the gas that's coming from the United States are associated gas, meaning that it's the gas coming along with the oil produced. So what you will be seeing is that as oil price goes up and down, it will also influence the gas production from the United States. Whether it'll happen, it remains a big question. Honestly, it's a bit too early to predict. But suppose that the United States will decrease their fracking activities. Then what you will be seeing, if you remember one of my slides where we look at the 3 giant drivers that could influence the gas price, then maybe the shale gas will be reduced. On a global scale, will it be good or bad? I do not have an answer today. But what it may bring is that the gas supply that were expected, previously we can expect somebody in the United States to start drilling a well and produce within a few months. Maybe if the United States government starts to slow it down, then maybe the US shale will not be able to produce as quickly. And therefore, other producers may be able to step in. So what we need to understand is that in a global market, everybody's responding to one another, right? Even let's say United States cannot develop the gas, then somebody else will. Like today, Russia is scrambling to build a pipeline to Germany. It's building a pipeline to China and to everywhere. So everybody's trying to grab a piece of the market. So this whole thing is a big question, right? I mean, because what happened in the United States, I'm sure when Joe Biden was elected as president, somebody in Russia and Qatar already start making plans of what's going to happen in the next 5 years, whether they're going to bring back more pipeline, more LNG plants, and so forth. So I do not have a quick answer. But yes, there is a potential that the production from the United States may slow down. So I guess that's all my answer. Thank you, Mr. Randy.
Can we just have one more question? Because we still have time for me. Okay, thank you to Mr. Putra. Okay, this is the last question. You explained the different country that different characteristic. Currently, the highest sector to give effect of gas in is power sector. How to decide which one sector is the best sector to develop the gas? To Mr. Putra.
Okay, thank you. Thank you very much. So to understand this question, this is a very good question. And that's why I actually spent about 5 minutes talking just about the power sector. So there's several considerations. Number one is that to look at the current state, right? That's why I spent some time to discuss that Indonesia today has quite a lot of coal-fired power plants, which means that we already have built a lot of power plants. And the question is, if we put gas into the system, will it be able to replace the existing fired power plants or not, right? So the number one answer would be to look at the present state. Like if you're in Vietnam and you already have 30% of your power coming from the power plant, it's perhaps a natural way for you to develop. But if you're in a country which is already overbuilt with other kinds of power plants, maybe it's not the best decision. So if you ask how would it best to decide, number one, it is best on the current state. Number two, it is based upon what is the story of gas for that country. What I mean is this: in other countries, gas could enter the power sector because it has a lower carbon emission. Compared with coal, in countries which has, for example, an emission tax, gas may be able to compete with coal. In countries which has a cheap gas, gas would be able to compete with coal. For example, in the United States. But in Indonesia, the gas price is still relatively high compared with the coal. So I would very careful in recommending gas use for power plants, depending on the context, of course. Now, so that comes back to the second question, is that if the power plant, if the power sector is not the best option, then what is the option? That's why I come to a conclusion that the only option and the best option for Indonesia is to go to the industrial sector. And how much sacrifice, if I may say, how much sacrifice we need to make in terms of government revenues or income, is a question for us. I do not, I mean, this is a lengthy discussion. We can talk more about the transport, the residentials, and so forth. One thing I do like to highlight is that Pak Joko Siswanto has highlighted earlier, the city gas is a very interesting proposition. But the question is, however, that recently the expansion of the city gas has mainly contributed by PGN and also by the state budget. So then it comes to the government to decide whether it's worthwhile to build a city gas. India, for example, out of their entire gas consumption, I think about 20 or 25% goes to the city gas. So it comes to the government to decide whether it's the way that it's going to go forth. But then there is a cost associated with each step. Yeah, I mean, I would like to have a much lengthy discussion on this because it's a very complex question. But I guess that's my answer for today. Thank you.
Thank you to you, Mr. Putra. Looks like we all answered the question. To Mr. Putra Diguna, is there anything else you would like to add or mention?
Yeah, I guess in closing, I mean, this is a very good event, and I really appreciate that we have a discussion here involving Agus from SKK Migas, Joko Siswanto as well, because we can see the different views, right? And I hope my presentation today also give a bit of stint of reality of the global landscape, because at the end of the day, I'd like to remind that it's not just about importing gas, it's about whether the gas supply at a lower price for Indonesia would be able to create an industry to compete with the global demand, right? I mean, if we want to make fertilizer, okay, fine, let's make it. But can it compete with India's fertilizer? I mean, we need to answer that questions, right? So at the end of the day, it would be worthwhile for us to look into it again, look at our assumption, especially in a post-COVID situation, to select the best industries for going forward, right? So everybody's looking at what our decisions would be. So that would be all. Thank you very much for having me today. Thank you and good evening.
It looks like we have covered anything. Thank you to you too, Mr. Putra Diguna. Okay, we shall continue on to the fourth speaker. This is Mr. Tamseng. The fourth presenter is Mr. Tamseng, and I will present to you the speaker's short biography. Mr. Tamseng holds a bachelor degree from the State University of New York and MBA in Oil and Gas Management from Robert Garden University, Aberdeen, Scotland. Mr. Tamseng has over 30 years experience in natural gas and natural gas liquid industry, including physical, financial, commodity trading, risk management, hedging, pipeline, midstream operation, transportation, and storage capacity, marketing, and risk control. Now, shall we begin with Mr. Tamseng's presentation, please, to Mr. Tamseng?
Sure thing. Can you hear me okay?
Yep, loud and clear.
All right, great, thank you. Greetings from the United States. Good evening. It's morning over here. Some of what I'm going to present will be really relevant in terms of some of the questions that were asked of Mr. Putra relative to the global markets and certainly the situation in the United States. those were some great questions, and hopefully we get to talk a little bit about that. I was asked to talk about the global LNG markets, and again, not to assume that everyone understands exactly what LNG is. We'll talk a little bit about LNG. So we'll walk through these topics. Exactly what is LNG and why? What's the importance of having liquefied natural gas? How is it transported? Who are the major consumers of LNG? Mr. Putra mentioned Japan. Who are the countries that are the major producers of LNG? What do we see kind of as the future outlook for LNG supply and demand? And then talk in some detail about the United States situation. How did we become an LNG exporter? What does the future hold? And certainly the issue was brought up about the Biden administration and hydrofracturing. So what is liquefied natural gas? You can see it's purified natural gas. In other words, you can't take the raw natural gas out of the wellhead. Once it's purified, it's chilled to minus 161 degrees Celsius or minus 260 degrees Fahrenheit. The raw natural gas has to have all the non-methane elements removed before liquefaction can occur. So the things that we see in a raw natural gas stream, such as the oily constituents, such as condensate, any water, hydrogen sulfide, which we know is a corrosive, nitrogen, oxygen, and carbon dioxide. Basically, they have no heating value, and that's really what we're interested in terms of methane. So we end up with what we call commercial grade or pipeline quality methane, which is approximately 98% CH4. So once we have that, then it can be chilled.
Excuse me, could I bother you for a second? Could you share the presentation?
Oh my goodness, yes, I'm sorry. That would be important.
Yeah.
Thank you.
Thank you.
Okay, can you see that now? Okay, my apologies.
No problem, sir.
So we'll just start with the the main slide, and then we'll start with the topics. And then what I was just discussing here was liquefied natural gas is methane. It's purified natural gas chilled to minus 161 degrees centigrade or minus 260 Fahrenheit. We want to remove all the constituents from the natural gas that we can during the processing and purification process. So we want to remove any condensate that's associated with the natural gas production, take the water out, the hydrogen sulfide, which I mentioned is a corrosive, and then the inerts, nitrogen, oxygen, carbon dioxide, they have no heating value. So we end up with what we consider commercial grade or pipeline quality methane, which should be about 98% CH4. So why liquefied natural gas? It's easy to transport a large amount of heat content. So it really is about compacting the energy and making it easier to transport. So for an example, if you have 1 cubic meter of natural gas, and let's say it has a heating value of 1,000 British thermal units or 1,000 BTUs, then if you were to take that same container and fill it up with liquefied natural gas, it would be 600 times the heating content, or 600,000 British thermal units. The LNG must be cooled and kept that way until it reaches a port and then is regasified and put into a distribution system. So from a logistical standpoint, you have to liquefy it, then you transport it, and then it's regasified at point of usage. So there's different ways in which this is accomplished. The world's largest integrated LNG project, which I'm sure every one of you is familiar with since it's a stone's throw from Indonesia, is the Gorgon project, this massive project off the northwest coast of Australia. So you'll have essentially a gathering system on the seabed floor, which brings the raw natural gas on shore, where it's processed and then is purified then it's liquefied, and then it's ready for either tanker shipments or to bring it on shore to Australia itself for domestic use. In the United States, we have a bit of a different setup. This is Cheniere liquefied natural gas. This was the first LNG export facility that was built in the United States. They are receiving pipeline quality or commercial methane directly from a large pipeline grid system that we do have in the United States. So you can see this was the first US LNG export facility. We call it the first in the lower 48. If you picture a map of the United States, Alaska and Hawaii are part of the United States, but they are not physically tied to what we refer to as the continental United States. There has been an export facility in Alaska for several decades, a small facility that was operated by ConocoPhillips and Phillips 66. So the Cheniere facility currently has 5 liquefaction trains. The output is about, right now anyhow, 36 metric tons per year. And you can see to the right there, this is actually from Google Maps, a satellite shot of their facility. It's on the Sabine River, which is the border between Texas and Louisiana on the United States Gulf of Mexico. So US LNG export facilities, you can see, are served by pipeline. Again, this is what differentiates our ability to export the natural gas. Is all the gas that's shipped through this pipeline grid has got to be of a certain quality. So again, as soon as it gets to the LNG export facilities, it's able to be liquefied. So on the left-hand side here, this is just a map of the transmission system for natural gas throughout the United States. And then on the right-hand side, there are 3 facilities. If you can see the little triangles, these are 3 LNG facilities in the United States Gulf of Mexico, in Texas and Louisiana. And you can see how they're fed directly with a pipeline system. So again, looking back at the map on the left, these pipelines reach every one of the producing basins. So in the United States, when we talk about, for instance, the shale plays, we're talking about the Marcellus and Utica Shale in the northeastern part of the United States. We're talking about the Permian Basin in West Texas, which right now is the largest producer of oil. And then several of the other key basins, the Eagle Ford in South Texas. So again, the grid, the whole idea of this grid, as you know, would be to make sure that the natural gas gets from the producing regions to the various consuming regions. You also have another way to produce LNG is with these floating tankers or floating LNGs, where they're basically just taking the gas off the seafloor, processing it and converting it immediately to liquefied natural gas, and then tankers can pull up alongside and the offloading can occur. And this is another type, again, of vessel, the floating liquefaction storage and offloading, or FLSO. Again, the idea being that the gas is brought up off the seafloor, or in this case, it can actually be domestic gas brought to the ship. It is liquefied. It can be stored. And then, as you see there, an LNG tanker can pull alongside and it can be offloaded onto that tanker. So for the transportation of LNG, you've got dedicated tanker ships that move this around the world. There are 2 main types. The Kevin Moss is the type that you see most often, with these spherical tanks that helps keep the LNG cool. There is some what we call boil off that does occur during transportation. Some of that actually, the LNG vapors off. Some of it is actually used to keep the remaining LNG cool. Also, some of it's used as a fuel for the tankers. I think everyone's aware that the maritime laws are shifting the types of fuel that can be used by tankers and ships in general throughout the world. Currently, you've got a lot of bunker fuel that's being used. There has been conversion to ultralight sulfur diesel. So in some cases now, ships are using ultralight sulfur diesel plus liquefied natural gas as a mixture. We foresee the situation where the LNG tankers will be the first to go to exclusive use of the LNG on board to fuel the ships, and then the LNG will spread as a cleaner fuel to most ocean-going vessels moving forward. The other major type is what's known as membrane. It's in the lower right there. These are insulated hulls. And again, in this case, they can actually take some of that boil off. The technology there allows them to re-liquefy that. So there's less loss in shipping LNG using one of the membrane type of tankers. Capacities range, the earlier LNG tankers, about 27,500 cubic meters to today, they're as large as 250,000 cubic meters. Global demand, based on some of the latest research that's out there, you can see 2019, the estimate was that globally there was about 350 metric tons consumed. In Europe, the LNG exports actually in 2019 increased by 74%. Huge increase of imports in Europe, but you can see some of it is this idea of getting away from coal and switching over to natural gas for power generation. Also, we've seen declines in areas such as the North Sea, so that there isn't as much natural gas as there used to be, and then less pipeline imports. Now, the previous speaker, Mr. Putra, mentioned, this idea of Russia building a pipeline over to West Germany. That could change certainly the amount of gas that continental Europe receives via pipeline. So we'll see what the outlook moving forward for LNG imports in Europe ends up being as a result of that. China, again, in 2019 was still the largest importer of LNG at 62 metric tons per year. In Japan, there was somewhat of a reduction in 2019. Over the past several years, as you know, they've been recertifying, relicensing the nuclear power plants and bringing that back up. So we saw a reduction in the use of natural gas for power generation in Japan. Also, both South Korea and Japan had a milder winter last winter, so the demand was not what it normally would be. So moving forward, you can see the estimate, and this data is coming from a report that Shell did. The estimate almost doubles, or actually does double by the year 2040, which again is only 20 years away. You're talking about a doubling of the global demand for liquefied natural gas to 700 metric tons. Again, pointing to China as the #1 importer of LNG, that essentially their growth is going to continue. They're moving away from coal slowly but surely. And so the expectation is that their current demand will double over the next 20 years. In South and Southeast Asia, demand is expected to increase by as much as 185 megatons in 20 years. And then, of course, LNG, as I mentioned, replacing bunker fuel for shipping. And globally, we think we're going to see less and less coal-fired generation. Again, in most places, again, as the previous speaker alluded to, in a free market situation, natural gas is very competitive with coal for generating power. And so we're going to see not only that, but the issues around the pollution coming from coal-fired power generation also has incented various utilities around the world to switch over to natural gas. And then here you can see sort of some major LNG imports by source. You can see basically they're in continental Europe. The sources based on color, you see there's Algeria, Qatar, Nigeria, the US sending a small amount to Europe currently, Russia, and then various others. And then, of course, the sources for Japan, LNG sources going to China, and then South Korea. So these are really presently your major markets for LNG. And then the exporters, these are your key players. If you look over there in column 2019, the bold numbers, you'll see no surprise. The big ones there are Qatar, really stand out, along with Australia, Russia to a lesser extent. For years it's been Qatar. Australia continues to increase their exports, and they will overtake Qatar, probably within the next couple of years. And this is sort of the logistics of, where is all the LNG coming from and where is it going to? You can see the blue lines are the various movement of LNG around the globe. More and more is coming out of the United States. We'll talk about that in a little more detail in a few slides. But you can see how much is coming out of basically Australia, and then of course the Middle East, where Qatar is. Pricing, again, Mr. Putra, the previous speaker, talked about the free market, and really there are different pricing mechanisms that are used in the United Kingdom. Well, it's part of Europe. It's physically separated from continental Europe, and they have there what they call a national balancing point. It really is kind of a paper point, if you will, for trading purposes. So they tended to price liquefied natural gas imports based off of the national price at this national balancing point. Continental Europe, they still use a basket that, as you can see, is somewhat tied to oil. So oil, and natural gas, the BTU pricing across those three is used as an average. And then in Asia, you have the Japan, Korean marker. If you go back years ago, most LNG was priced based on what was known as the Japanese crude cocktail. It was an average price of imports of crude oil, and they were basing natural gas imports based off of the BTU pricing for crude oil, which you can imagine was considerably higher. In fact, it's pretty much believed that once the United States started to develop the export projects, that a lot of Japanese purchasers of LNG renegotiated their contracts. They wanted to be able to purchase more LNG on a natural gas-based price, since they knew that they were going to eventually be able to get gas from the United States, and that would be priced at a U.S. market. So you can kind of see the average price delivered for LNG in October, based on the JKM, was about $4.55 per MMBTU, and the average price expected by the end of November would be about $4.75. Now, in North America, we have a futures market, the New York Mercantile Exchange. You can forward buy and sell natural gas delivered in South Louisiana at the Gulf of Mexico. And so we have a futures contract. It's a financial contract. And so really in the United States and for most of North America, that's sort of the key marker price that we look at, and everything is priced back off of that price. So you can see for November 2020, the settlement price was approximately $3 per MMBTU. And again, that's in South Louisiana or the Gulf of Mexico. If you add on liquefaction cost of about 50 cents, and then a transportation estimate, 70 cents would get you to Europe and about $1.90 to Asia. For instance, if a buyer in Asia wanted to purchase LNG for next month's delivery, December, we would be using the November pricing, and it would be about $5.40 currently delivered to Asia. Future growth. Australia is going to continue, as I mentioned, to increase the amount of LNG that they're currently exporting. They will overtake Qatar, but Qatar will remain a large player. Nigeria is still a large player. This project off of the coast of East Africa, Mozambique, this is a joint venture between, well, I say joint venture. Both Exxon and Total are looking at this project. Again, it's going to be an integrated project. It's going to be the offshore drilling, and then the production will be brought to a purification and processing facility, and then to a liquefied natural gas facility. Total reached a final investment decision this past year on the project. They're going to go ahead. Exxon has not reached the FID yet. However, they are in talks with Total. They're looking at potentially developing this massive field together, again, for the purpose of efficiencies. So you can see right now, if the project moves forward, the first deliveries are expected in 2024, and they would start at a rate of about 12.9 metric tons per year. Malaysia is still producing a good amount of LNG and continue to. And then, of course, the United States. We are an up-and-coming player, and I'll talk in a bit more detail as to why that is and what the prospects look like for us. So you can see in the United States, the question becomes, why would the United States be an LNG exporter? For years, the United States was an LNG importer. We have about 5 facilities that were designed to receive the LNG and regasify it and put it into our pipeline system. However, can everyone still hear me?
Yep, loud
okay, thank you. Sorry, I just didn't know if my apologies, my phone went off and I thought I was being notified by one of the moderators. So essentially what happened was when they perfected the technique of hydrofracturing, which we'll talk a little bit more about in a minute, all of a sudden we were able to release reserves of natural gas that previously could not be extracted. And we found ourselves producing more natural gas than we actually were consuming. So immediately the producers in the United States needed additional outlets. They needed something beyond the standard domestic demand for natural gas. And so they started talking about, kind of the what ifs. And then, of course, we had, as you all know, in March of 2011, you had the Fukushima nuclear disaster in Japan. And they immediately shut down on the nuclear power plants, and they were relying solely on liquefied natural gas for fuel to generate electricity at the power plants. So that caused an immediate spike in LNG prices in Asia. I believe back in 2011, I think we saw upwards of $14 per MMBTU. So you can sort of picture producers in the United States, number one, saying, hey, we're starting to produce more than we are consuming as a country. And number two, look at these prices in Asia. But there were absolutely no LNG export facility. Sparked the idea that LNG should be exported from the United States, that we should build these facilities and that we should search for markets. So just to talk a little bit about the horizontal drilling. Horizontal drilling has been around a long time. I think any of you familiar with this know that. I mean, if you're putting a pipeline under a highway, a river, a lake, if you're moving just, for instance, for cable television or telephone cabling, fiber optic cabling, and you want to go under a road or highway, you do use horizontal drilling. The difference here was it allows the producer to go in and go across the entire pay zone, the area where the natural gas is trapped. So you can see in this first graphic on the left, you literally can go under housing additions. In the state of Texas, in the city of Dallas and Fort Worth, there actually is what is known as the Barnett Shale, and some of that shale is below existing buildings, and so they can literally drill down and under. And in the middle diagram here, this illustration, the hydrofracturing is really just the extraction method. It's the completion method. So you're pumping in extremely high pressure water, in some cases a gel. There's a little bit of a chemical component, and then sand also goes in there. The sand is to keep the pores open. Once the shale has been broken up, you don't want it to close back up again, so that the sand becomes a filler. So it's the hydrofracturing in tandem with the horizontal drilling that has allowed us to produce as much as we do. And if you, again, looking at the diagram on the right, essentially this is what we're accomplishing. So this lower area, this tan area, is where you would find the oil or natural gas. Normally you would drill down vertically and you could complete a small area, and you'd have to do multiple wells. So essentially what we're doing now is we're taking one well and we're boring through the heart of that pay zone, the heart of where the oil and natural gas are trapped. and we're extracting a considerable amount more on a daily basis. So as you can imagine, yes, we're pulling more production out, whether it's natural gas or oil. So the deliverability, the sales volumes are very high, but we're also draining this reservoir quite a bit faster. So that's definitely the obvious downside of horizontal completions and hydrofracturing is you're going to have a decline curve that's very rapid. So you kind of see my footnote here at the bottom. You know, in the United States, the states get to dictate the rules in terms of drilling, the permits, the offsets, and also they get to state how long these laterals can be. So depending on the state, some of these laterals, as you can see, can run as long as 10,000 feet or about 3,000 meters. So most recently, we have gotten up to about 10 billion cubic feet per day equivalent for liquefied natural gas, or about 286 million cubic meters a day. We have 7 active LNG export facilities currently that have a total capacity of about 10.5 billion cubic feet per day. So we're almost at maximum right now. But there are 20 approved liquefied natural gas export facilities still that are on the books. They've been approved by the United States government. These alone represent an additional 24 billion cubic feet of capacity, again, LNG capacity for exportation. The Panama Canal expansion has greatly helped U.S. exporters of LNG because the much larger ships can go through there now. So we are able to increase the volumes moving to Asia from just a few years ago. And of course, the success of horizontal directional drilling and the hydrofracturing brought us to a record amount. Again, obviously, this is pre-COVID, but back in January of this year, we hit a record total of 95 billion cubic feet per day of dry natural gas production in the United States. And our consumption is considerably less than that. Again, as we all know, we'll have to see what happens, but you know, we are optimistic about the potential of a vaccine, getting our economy back in shape, in which case I think we will see a return to these higher levels of production. Now, in terms of our ability to export LNG and whether or not that's going to increase, I will say that the current atmosphere in the United States, at least, we're going to see a decline in the domestic use of fossil fuels. We just are. This was going to happen pre-COVID regardless. But the thing that COVID has done is kind of caused a chance to reset. So in some cases, you can see there's going to be forced reduction of fossil fuels. For instance, in the state of California, the city of Oakland recently banned the use of natural gas in terms of building new homes. So new homes in Oakland, California will not have natural gas service. They'll have to be totally electric. Again, there are questions about the Biden administration. As Mr. Putra mentioned, the question came up. We really don't know. You know, we've heard, you know, that initially Joe Biden was going to ban fracking. I don't think that's going to happen. I think it's really going to still be left up on a state-by-state basis. For instance, the state of New York here does not allow hydrofracturing, even though they have a substantial amount of what's known as the Marcellus Shale in New York State. They are not going to allow hydrofracturing. So we'll see what happens. Again, I think, believe it or not, part of it comes down to whether or not the Republican Party in the United States controls the U.S. Senate. If they do, and then they can block some of what the Biden administration might want to do in terms of restrictions on the oil and gas industry. So that's kind of a wait and see. But we have had issue with a lot of pipeline projects being protested and lawsuits over those. So while we might not see a fracking ban, we may see problems in terms of our ability to actually move the natural gas to the market, get it to the LNG facilities. And then, of course, there's a lot of green initiatives. You've got corporations now that are, shareholders are asking them to talk about their ESG. What are their policies on environmental, social, and governance? And so that's going to make them sort of take a look at their own use of fossil fuels. And I kind of alluded to this earlier. I think we're in a situation where, unfortunately, COVID has forced, as we know, a dramatic drop in demand for fossil fuels. So I think you're going to find certain companies and organizations now stepping back and saying, well, wait a minute, we've cut back on our current use of hydrocarbons. What can we do to not return to the level of fossil fuel usage we had pre-COVID? In other words, what was our carbon footprint? What is our carbon footprint now? And do we really want to return to that? And I think there's going to be some social pressure to not return to that level. So again, sort of as a general statement, I see production in the United States getting back to where it was. I see demand declining. And so really the only solution for the oil and gas industry in the United States is going to be exports. We are going to rely on that exportation. Prior to, if we go back just to March 1st of this year, the United States was setting records in terms of exportation of crude, of all petroleum products, and natural gas. And so I think we'll get back to that eventually. And I think the whole world, we're all kind of holding our breath. But I do believe that we're going to be able to substantially increase the amount of LNG that we export. And we certainly, as I mentioned, with things like the Panama Canal expansion, we will be able to direct more and more of those exports to Asia. So if Indonesia does find itself in a situation where, you end up being net importers of LNG, I believe the United States will be in a situation to be one of your key suppliers. Thank you.
Okay, thank you to Mr. Thompson, such a tremendous presentation. I hope this presentation will give all the participants insight about the global outlook of natural gas. To shorten our time, shall we begin to Q&A session to keep this on schedule? Okay, we have gathered all the questions for the participants. I will tell you the first question. Okay. This is two questions, but the question is relevant each other. Okay. The first, why US start develop the shale gas recently, not earlier in 80s? What US vision for natural gas business upcoming for this next 10 years?
I didn't catch the first part of it.
Okay, I will repeat it to you. Why US start develop the shale gas recently, not in earlier 80s? What?
Oh, okay. Yeah, they didn't have the technique to break up the shale. The hydrofracturing had not been perfected. Mitchell Energy out of Houston, Texas, really perfected the hydrofracturing technique in about 1987 or so. And so it's very costly. That's the other thing. These are the most expensive wells to drill and to complete. And so, it kind of gets back to, if there were to be a ban on hydrofracturing, then we would return to vertical drilling and the old conventional types of completions. But it's a very expensive process. And so you had to have a market price that would support that. And then I apologize. So the second part of that, over the next 10 years, as I mentioned, I think over the next 10 years, we're going to see growth once things return to normal. Beyond that, though, 2050 seems to be a big target for a lot of companies. I know, for instance, BP and Shell and others have talked about their green initiatives, and it seems like everyone is targeting 2050. So the next 10 years, I think, look pretty good. But as we get towards 2050, a lot of these goals are to reduce the usage of fossil fuel considerably.
Thank you, Mr. Thompson. Now, shall we continue to the second question?
Sure.
I think it's also interesting to you. From your expert judgment, what is the optimum transportation method for small-scale LNG? Is it better to build a small volume LNG carrier or converting normal vessel to LNG carrier?
Yeah, I think it's at the present time, it's cheaper to build the small LNG carriers than to try to do a conversion.
Okay, thank you, Mr. Chamseng. Oh, wait, there's a new question. Oh, okay. Looks like we have answered all of these participant question. Is there anything else you would like to add or mention, Mr. Chamseng?
Well, I just think that, all of us, we're all kind of holding our breath. We're very optimistic, hopeful about the vaccine. And so that things, globally can return to normal. And I think that when they do, I think that the future of LNG globally is very bright, as we still have countries such as India and China trying to move away from coal. We have other developing countries trying to get away from coal. I think, natural gas will be that, we refer to it as the bridge fuel. It's cleaner burning than coal. It'll get us to the point where we can develop alternative renewable sources of energy in the meantime.
Actually, there's so much demand about the new question. Could you please give some time? Oh, sure.
Yes.
Thank you very much. Thank you. Appreciate that, sir. The next question is, how the prediction or forecast about upstream, especially for gas production after U.S. elected the new president that will stop gas fracturing in the U.S.?
Yeah, I kind of touched on it. I do not believe that he will be able to do that. I really don't. I don't think the federal government, now the federal government can certainly put a ban on hydrofracturing on federal lands. So where they are the owners of the mineral rights, they can do that. I just don't think, I think there'll be too much pushback. We have an interesting situation at the present time. The way our structure is, you have our president, our executive branch, and then you have the legislative branch, which is the U.S. House of Representatives. There's 435 members, and that's controlled by the Democratic Party right now. At the present time, the Senate, which is 100 members, every state has 2 members. It's controlled by the Republican Party. There are these special elections going on in the U.S. state of Georgia in January. If the Republicans retain control of the U.S. Senate, they will make sure to block any legislation that the Biden administration might propose that would ban fracturing. Now, if the Democrats gain the Senate, then they will control the president and the 2 houses of Congress. They may be able to pass something, but again, I think there'll be too much pushback, and I think there'll be jobs at stake. And so I just don't see it as happening.
This is the last question, actually.
Okay.
How to win in the new LNG post-COVID-19, especially in environment, capital efficiency, supply chain, downstream, market development. How do you think about that, Chamseng?
Well, I think we have everything in place. I really do. I think it's a question of, as Mr. Putra had mentioned, the free market's going to dictate the price of natural gas globally. And I think we can get back to where, if we can get the vaccine, if the economies, start to churn again and get back to where they were, you cannot increase economic activity without an increase in energy. And so I think things will just naturally fall back into place once we get prices that will support the increased production. There were a lot of wells in the United States that were never completed. They were drilled, but the price is not sufficient yet enough to complete that. So I really think, and maybe people will be surprised, but I think once we start to see positive economic growth again, the energy infrastructure, the energy system will follow. We'll see additional production. We'll see new drilling. we'll see increased exports of LNG, and all of those things will just fall into place.
Okay. One more question?
Sure.
Okay.
That's fine.
Okay.
Whatever time you have.
Yeah, I think we still have the time, Mr. Samseng.
Okay.
How long will this domestic gas supply last? Can U.S. shale gas remain competitive at such low prices? Will supply constraint within the U.S. cause delay for LNG projects? Realistically, what is the LNG export potential from U.S. in the next 3 or 5 years? Will Canada eventually become an exporter of LNG, and how will this affect to U.S.?
Sure. Thank you. That's great questions. First of all, I think, as everyone knows, the economics are going to drive the projects. So I kind of mentioned, we already have 7 facilities up and running, and so they're successful. The 20 that have been proposed, they may not get to a final investment decision. It will depend on the prices. I can say from a standpoint of U.S. prices, the natural gas prices spiked over the summer. They've fallen back down below $3, but at $3 per MMBTU in the United States, that's a profitable number. I would say that below $2, it's not profitable to produce gas in the United States using horizontal drilling and hydrofracturing. So again, if you see those dips, you realize then that we're probably going to be cutting back on the production. But if we're anywhere from $2.50 to or higher, then you're going to see a lot of U.S. production for natural gas. I think, again, from a growth standpoint, I think right now, as I said, we have the capacity to export the equivalent of 10 billion cubic feet of natural gas per day. I think within the next 2 to 3 years, that'll easily be 15. I think 5 years from now, we'll be at 20 billion cubic feet. Yes, the Canadians are looking at building pipeline to their west coast to be able to, and then build an LNG facility to export over to Asia, to the Pacific Rim. So I think that will happen. Now, again, the Canadians are much more environmentally defensive than the United States is even. So there may be issues with this pipeline and with even citing that LNG project. So that's kind of a wait and see. I should mention there is a new project that's going to be built on the west coast of Mexico, actually on what's known as Baja California. So that will be able to serve Asia directly as well. That's just in the announcement stages, but it will happen, and it will use domestic Mexican natural gas, as well as natural gas coming from places like West Texas, where we can actually deliver it by pipeline across Mexico to that new facility. But again, it gets back to, it gets back to the free market situation. You can't have all these projects, right? If you do, then the price will fall, and then it won't be economic to do it. So it really will be a question of what do global prices look like in the future.
Thank you. It looks like we have all covered everything. Thank you. Thank you so much, Mr. Samseng.
My pleasure to be with you.
Thank you. Okay, looks like we have going to the closing. Okay, thank you to all. I will speak to you about the closing speech. Dear ladies and gentlemen, with my co-moderator, and I would like to conclude the first day of ICGMET 2020 webinar with few tools that we have learned in 4 hours conference. For the first speaker, based on Mr. Agus Budianto presentation, he said that oil gas business are generating multiplier effect. In investment in upstream business in Indonesia is more attractive to investors since still promising the significant return. In order to survive during pandemic period, SK Kamigas initiative initiate several fiscal incentives for upstream activities. 10 strategic pillars and enablers are divided into 22 key programs to achieve SKKMIGA's long-term plan. Significant gas base load demand can be created and developed of new projects such as petrochemical plant. RDMP project will require a massive gas supply, and based on presentation, in order to meet the development of gas demand, gas infrastructure and interconnection will be the main key. For the second speaker, one key that Mr. Agus mentioned is gas infrastructure aspect. It's related with Pak Joko Siswanto presentation about natural gas infrastructure development. Indonesia needs to be ready in 2035 to develop gas that the country will not export based on President Regulation number 22, 2017. In primary energy supply and demand, it has surplus in gas demand. For national gas balance sheet, existing supply has not sufficiently met the demand from gas based on contracted demand. Role of gas in reducing LPG and gasoline import that describe there is added 1 million per year additional LPG from rich gas. Then the gas infrastructure, which the main project of infrastructure to support the fulfillment of Indonesian natural gas, need to be optimized. The utilization of natural gas proposed to fund by APBN or BUMN for the transition construction. And lastly, the gas emission reduction that describe fuel switching can be reduced that CO2 emission constantly for 10 years. For the third speaker, the part one explained about the evolving gas market. The point to evolve gas market, that's when we know that different country has different characteristics, different market demand, and also supplies. And the part two, investment require credible projection, like shown in Indonesia gas, that Indonesia need to be carefully in how much infrastructure need to build for support the gas demand. The part three is a briefly upstream of story of continued volatility, how Indonesia need to take risks. Indonesia need to ready to recalibrate the baseline and recent pathways ahead. It need to look the history of the market, present and future as the challenge to take its a plan ahead. So we have to see what happening in Indonesia and overseas. So we have to be careful in planning. Okay, and lastly, the fourth speaker is, first, we have to know the LNG definition. LNG is purified natural gas, methane, which are all non-methane need to remove because we disturb the facilities. Then the pipeline for quality methane is 98% LNG. Is why LNG, because it's very easy transport, larger than heat content. Okay, Chinese LNG USA pipeline quality from large, and lastly USA export LNG with some facilities that consist of active LNG facilities produce 10.5 BCF per day, and approved LNG export facilities produce 24 BCF per day. And then Panama Canal expansion, increasing volumes. Asia record high natural gas production January 2020 is about 95 per day. I hope you have a great day this, and don't forget to attend the second day. It will be more extraordinary. As moderator, I will give you the greatest appreciation for your participation. Thank you and have a wonderful day. Me, Randi Maulana Nasir, and my co-moderator, Fatima Vanessa, sign it off. Thank you. Assalamualaikum and good night to all.